All right, guess it's time to get started then. Welcome, everyone. It's a pleasure to be able to welcome all of you again. And this time we also have a quite an interesting session. Personally, I've been doing quite a lot of GitOps-y things previously, so this is super awesome to be able to present these very important speakers in this area. First of all, we will have a short introduction after I'm done about GitOps, the term itself, by Alexis from Weaveworks, and then followed by more specifically a toolkit for GitOps things from Stefan. And afterwards, we will have some Q&A, and during the talk, you can post your questions on either the Slack channel or on the YouTube chat. So first of all, the team hosting this is Cloud Native Aarhus, which is part of this Cloud Native Nordics community, where we host tons of different meetups. In the past, they typically was face-to-face, but obviously, given the conditions at the moment, we are doing it virtually, but that also means that we can find very interesting speakers and also be able to broadcast these talks to much broader audiences. So pretty cool. This is just the organizer team at the moment. If you have some interesting talks or suggestions to talks or something like that, feel free to reach out to any of us. We are definitely open to any suggestions you might have. Just a brief overview. We have quite a lot of different groups in Cloud Native Nordics. So perhaps once this COVID thing is getting a bit better, you can most likely find more interesting talks more close to you if you prefer to attend these things in person. All right. As I mentioned, Tech Talks channel and Cloud Native Nordic Slack. If you're not already on it, you can visit the website and put in your email, and then you'll get an invitation. And also the chat on YouTube. Yeah. So today, as I mentioned, Alexis Richardson will talk about the GitOps. He has been, he's a former chair of the Technical Oversight Committee for CNCF. I believe this is the first time we have a former chairman presenting something like this in a Cloud Native Aarhus event, at least. Previously has been at Pivotal doing lots of different awesome things with very well-known products, as you can see. And then we also have Stefan, which has been done a tremendous amount of work in the open source space. I've definitely had an eye on some of the projects before, Flagger, one of them, and Flux has also been something I've tried out. So I'm super excited to see this GitOps toolkit and what it can bring to the space. Yeah, I guess we should just get going and see what Alexis has to share.
Many thanks, Mike. Can everybody hear me?
Yeah. Yes.
Great. Okay, so I'm going to present, and oops, I've got, we have a fairly tight schedule today, and I'm sure many of you have heard a little bit about this before. So I'll actually go a little bit quickly. The slides will be published, and when they're on video, of course, you can slow it down, and that'll be fun to listen to. So a bit about me. Thanks for the intro. That's my Twitter handle, and you can email me if you have any questions. A really good example of GitOps in practice that I highly recommend that you read about is the Mettle platform. And I'm mentioning this partly because I think the last Nordics featured Steve Wade talking about what he did turning Kubernetes clusters into cattle with some tremendous productivity gains shown here. I think this is really a very compelling business case. If anyone says, hey, how do we persuade the boss about this? Show them this stuff. Please do. It will work. And what do we mean by when we say GitOps? It's really two things. Best practices for operations, specifically around automation and reproducibility, standardizing how people operate apps in multi-cloud environments or hybrid or other Kubernetes use cases, and making it easy for developers without getting too much into the details. It's also some new technologies. So unlike DevOps, which was really about practices and kind of a family of related tools, in GitOps, there is a very specific set of tools that are recommended, some of which have been created by people speaking on the today. Others have been created by other communities, other companies. There's a wide range to select from, but it is a technology-driven trend. And I also want to mention that it's not just about the tools and the technologies, but it is a community. And here is the link to go to later, which features great information to learn from, videos to watch, slides to see, places to ask questions. So you may be wondering, I've heard of this GitOps thing. Am I already doing it? Because it sounds like kind of familiar. And you probably do know some of the techniques already if you've been doing any kind of DevOps or infrastructure as code or some of the continuous delivery techniques. And here I'm listing just some of the giants that we stand on today, whose terrific work went into the technologies and practices that we'll be talking about in this presentation. So do I need GitOps? That is, I think, a key question. You may not. The way I see it is this. Do you feel like you're getting stuck with your operations in some way? You know, how does that manifest itself? Well, there are several different ways that you might detect that you are stuck. One of them is people are afraid of making changes because they don't know if their system is in the right state or not. And when it comes to making copies of their system or upgrading it, people are fearful because it's not a robust process. It's difficult to make copies of the system. They can't be shut down and restarted easily. They are not, in the words of somebody, cattle. They're actually snowflakes. Each cluster and each stack is totally unique. Nobody dares touch it in case it disappears. That's not a great place to be. And we see this again and again and again. Another phenomenon is it easy to deploy applications? Can I do continuous updates? Can I do verification? Can I automate my operations for apps, services, and platforms? What if a team says, I want a machine learning cluster? How do I do that? And many other questions, especially around scale. And so this occurs when we reach the limits of manual changes. So here's a little story to show what I mean by that. So in many places, production is basically a black box, and that's a good thing if you don't want anyone to mess with production, but it can be tricky when you want to see what's going on. And we have tools like observability tools for interacting with the black box, and we can instrument our code to make it more observable, and many other things that we can do to help with observability. One of which is to interact with the system. We can push changes and we can look at the results using simple changes like kubectl apply or a GUI, or updating a container and then having some kind of CI process, or updating the config by hand. But we can then observe the results, and we might have another GUI to look at that. So we can make small changes and look at the results to see if they're correct. Make another small change, look at the results to see if it's correct. It's a bit like making one of those plasticine movies, like Wallace and Gromit. And when we have a black box type of single system, some manual changes are okay if they're simple or atomic, and if they're easy to observe and verify, or they're in development and we just don't care. Then it's okay to use manual approaches or have little scripts in your CI tools. The problems arise when you try to do this a lot, whether it's more clusters, more apps, more teams, more changes, more automation across fleets, more changes per day. And here are just some of the examples. You know, what if you want to know that what if some of your components are or are not in a correct state? Or what if you have a fleet and you want to roll out some kind of patch, maybe incrementally? What if you want to boot up 10 identical clusters, but then do an update immediately before giving them to the app teams? What if you want to do an upgrade while keeping some other parts available? What if you want to use feature flags? These are all things that are difficult with a single system, manual, black box interaction approach like I described. And really, this is all about pointing towards an automated world, the kind of world we think about when somebody says, hey, apparently at Google, they just have one administrator and they use rollerblades to get around the data center. And when something blows up, they just swap it out for a new box. Well, that's a pretty amazing sort of automated world if you can make it work. For real folks, it comes down to programmatic guarantees that changes are correct, which can then be composed into larger scale, more complex changes, which can be automated. Otherwise, errors will creep in. And you'll see this when you're using, for example, a CI tool to do too many updates at once. If something goes wrong halfway, you'll end up in a partial failure, partial correct state, and you don't know what to do. So you usually have to roll back right to the beginning, and that's not good. This is essentially reiterating this point, just summarizing. And finally, there's another point to make. If you push changes manually, that may be a security threat vector. If somebody hacks into your CI and you're making changes from CI, that could be a way into your production systems. So by contrast, we believe operations are not frozen and can be automated when we use GitOps. I often get asked for GitOps in a single sentence. Here is my attempt at that. Compare the running state of our system with the desired state, do that continually, and whenever they get out of sync, force them to converge back to the correct desired state. So it's all about reconciliation and automating that, which means we don't any longer have a dependency on the sort of black box manual guesswork way of management. We have automation that gives us reproducible ops at scale for many different cases. So how is that working? We have a description of the entire system that is declarative, and this is much easier in Kubernetes than many other tools, but it's not unique to Kubernetes. We keep a canonical desired version of that in Git. We apply approved changes automatically, and we have software agents to ensure that is correct and alert us on drift. Flux is one of the tools that you can use to do this, and afterwards, Stefan will talk about some new experimental changes in Flux that are very exciting. Flux runs as an agent inside Kubernetes and observes the state of the cluster for you. It can see everything because it lives inside Kubernetes, and it can then compare what it sees with the desired state, which is in Git, in the config files, and the image repos. And of course, when those diverge, then an update may be triggered, and then the system can reconcile itself and pull in changes and make things correct. And because it is a Kubernetes operator, it inherits all of the nice things that Kubernetes gives you, like lifecycle, scalability, security, and policy, many of which you don't want to rewrite for yourself in a new way. And so this reconciliation is key. And there is some confusion around it because some people say it's only triggered by a pull request merged in Git, but actually there are many ways to trigger a reconciliation. The point is you're always driving the loop. The loop is always getting you into a correct state and telling you if you're not in a correct state. And you can do this for anything you like, up to any scale you like. And so this gives us freedom from this frozen state to move quickly without fear, to do app deployment, app updates, to verify correct deployments, to do CI/CD securely in a modern way for Kubernetes, and to do cluster automation for lifecycle, or do progressive delivery, or even have a consistent way of doing all of these things across multiple clouds and data centers. A few final takeaways for production users. You can use any CI tool with GitOps, but it is additive. CI is not a way to do GitOps. You need to do some GitOps tooling plus some CI tooling. You shouldn't depend on CI 100% for all things GitOps. Enterprises will ask you for scale and security. Things to look at here include templates and programmable infrastructure tools that are emerging. Here are a few that are listed. And you should be familiar with Git's security model as well as Kubernetes RBAC to be secure. And finally, a GUI is one way to make changes in a system. Don't throw it out yet. There are GUIs coming that are more GitOps friendly, that show things that work really nicely with this practice. Plenty of use cases are out there. I mentioned Mettle at the beginning as a good one to read about in detail. Plenty of tools. And it's not just about Kubernetes. Lots is going on here. It's very exciting. You can find out more on the GitOps community site and hopefully from Stefan, who's speaking after me, I believe. Thank you.
Thank you, Alexis. Yeah, go ahead, Stefan.
Okay, I'm ready to take over. Hello, my name is Stefan Prodan. I'm an engineer at Weaveworks, and I'm very glad today to share with you some things that we've been working on inside the Flux CD organization. If you don't know Flux, Flux is an GitOps operator, we call it. Like Alexis said before, it's something that you run in your cluster, and it synchronizes your cluster with a Git repository. And over the years, we gathered a lot of feedback from Flux users. And this is our attempt to address some of those feedback and ideas. And the GitOps Toolkit is something that's currently in experimental mode. And we encourage anyone that's interested in these ideas and in the future of Flux or the future of GitOps itself, please reach to us and let's get Flux V2 right. Okay, so what is the GitOps Toolkit? The toolkit is composed out of a series of APIs and specialized tools. Now, some things that we define how we build these tools will be using the Kubernetes controller runtime libraries. And we've already developed 2 controllers that are part of the toolkit, and they are we've used KubeBuilder, which is a great framework for developing modern operators on top of Kubernetes API. For the toolkit itself, what really matters here is the fact that these APIs are not just REST APIs that our components are exposing. Everything is done through the Kubernetes API. So we use custom resources, and you can drive operations through Kubernetes custom resources, and that's about it. We define the scope of the GitOps Toolkit with many things here. Most of them are gathered from, like I said before, from the feedback we got from Flux users and other GitOps tools. We define as the first major thing source management. Like, we need a way to manage sources inside our clusters. We want to address Kustomize and Helm as our main technologies, how you can define your cluster state, how you can template them and customize them. But you'll see further down the line that you can easily extend the toolkit with other tools. So these are just 2 technologies that we currently support in Flux, and we'll keep supporting them further down the line. Now, in terms of how we do reconciliation with the GitOps Toolkit, we define 2 ways of doing it. One is on a schedule, like Flux does today. So basically, you say, I want to check my cluster state and correct the drift if a drift has occurred every couple of minutes, or you can set whatever schedule you want. So this is how currently Flux works. What we want to add here is an event-based reconciliation. We want to react from external events, let's say a Git push to a branch. We want to be able to listen to that event through, let's say, a webhook receiver. And from there, an event will be issued inside the cluster, and the reconciliation will take place. And in the past, it was this discussion about pull and push, that Flux is only pull mode and GitOps is only about watching changes in a Git repository on a schedule. And I think GitOps is not defined by the pull model. The pull model is great because you can detect drifts on a schedule, but it should be easy to react to external events as well. And this is one of the things that the GitOps Toolkit tries to solve. If you look at these features, you can notice that most of these things look like a decomposed Flux into multiple components. And this is exactly what we did without reusing Flux source code. The GitOps Toolkit is fully rewrite on top of the Kubernetes cluster libraries. So we also want to easily integrate with Git providers. If you are using GitHub, GitLab, Bitbucket, or other SaaS offering, we want to make it very easy for you to provision and work with these repositories hosted on these providers. And finally, we want to have an interoperability with the cluster API providers in a way that you can drive fleet management and cluster lifecycle through GitOps. Now, at the core of the toolkit is a controller called Source Controller. What Source Controller is doing is allowing you to define sources inside your cluster, be it, let's say, a Git repository or multiple Git repositories, Helm repositories, and in the future we'll be looking at other sources as well. The idea behind the Source Controller is to have a dedicated component that exposes inside the cluster the actual manifests. So Source Controller doesn't reconcile your cluster in any way. It reacts to source events and produces immutable artifacts inside your cluster. And those artifacts could be identified, for example, by a Git SHA, by the Git tag, or let's say a Helm chart version, and so on. And what's important for Source Controller is not only to acquire these artifacts and deal with authentication and authenticity, but Source Controller should also emit Kubernetes events and notify all the interested parties in those source changes that something happened, right? So Source Controller is broadcasting every time it acquires a new version. This is how it could look. Some things here are not quite implemented. Currently we have two custom resources. One is called Git repository, the other one a Helm repository, and I've put here an example how you can declare a source inside your cluster. You reference a Git repository through a URL. You can specify a secret where your authentication is, for example, SSH keys, known host, and so on. And you can also tell the Source Controller to verify the authenticity of changes by using PGP keys. And all of these features are currently in Flux. What's new here, maybe you notice that the reference, I'm setting the reference to a SemVer expression. What that means is that you can tell Source Controller, instead of just following a branch or a Git tag, it will watch for releases of in your repository for tags. And if those tags are in SemVer format, then it will fetch the latest release tag based on a SemVer expression. And this is how, for example, you can drive deployments on production systems only from SemVer releases. But this is just one option. You can still use branches or tags, or you can even pin a repository to a particular commit in a particular branch. So there are a lot of options here on how you can define what reference from inside that source you want to make available. If you notice here in the diagram, there is also an S3 icon. The idea is we've seen this with Flux users, that maybe you have an encrypted S3 bucket that has some secrets inside, and you want to, besides Git or other sources like a Helm repository, maybe you want to fetch something from a bucket. So this could be a potential new feature in the source controller at some point. So the idea is source controller fetches all these resources and exposes them inside the cluster as artifacts. Then you have consumers that are notified through Kubernetes events, hey, there is a new artifact. And let's see what type of consumers you could have. One group of consumers, we call them specialized reconcilers. So currently we have developed a controller called Kustomize Controller that can reconcile your cluster from sources that contain plain YAMLs or customized overlays. And in the future, we'll be developing a Helm controller that has a reference to a Helm repository and a particular Helm chart version. And as an idea will be a fleet controller that can orchestrate this across multiple clusters. The important part here is that all these specialized controllers will be using the source API package to be notified of changes in your sources and to be able to fetch the actual artifacts manifest that it needs to apply.
So sorry to interrupt you, Stefan, but one question from the chat is, I'd be curious to hear how this new toolkit intersects with the GitOps engine direction. Is Argo planning to use some of the toolkit? Is there a collaboration with the team on those components? Alexis might also answer. Well.
So the GitOps engine does not have a source controller component. That's part of Argo CD. You could think about the GitOps engine could be one of the consumers of the source controller. It's all up for experimentation. I don't have an answer yet.
Yeah,
that should be totally possible.
Reached out to the community. The toolkit is more of a framework for building things that contain the components that you want. And one of the components that we know some users want is the Argo CD application model using the GitOps engine for the reconciliation loop. And as Stefan said, that's something that can be plugged into this framework and gives us a way to interoperate for people who want that model as a profile. But there are other things that you might want to do with it, which we'll have some more examples of later on. I think with all these things, it's a process of discovery because we need to be driven by use cases. But they can be fit together in that way if that's the right thing to do for the use case. Okay, but they're not the same thing, to answer clearly. GitOps engine is a specific reconciliation loop tool influenced by Argo CD and Flux version 1. And this is a more general tool for building your own solutions, including a version 2 of Flux.
And it's all, also to clarify, it's all in a very early state. So not all of these things are even, as far as I understand, don't know all of the parts of the direction either. So I think feedback is welcome, right?
Yeah,
that's true.
Okay, moving forward. This is how cluster management could look like when you mix and match multiple controllers that are part of the toolkit. Source controller will look at all the sources. So a cluster admin can add, remove, or modify sources on the go. Then a cluster admin, after it adds these sources as trusted sources inside the cluster, could use Kustomize Controller, Helm controller, or other types of specialized reconcilers to define the cluster state from all these sources and Helm repositories. want to talk about Kustomize Controller for a little bit. Kustomize Controller tries to address a couple of feature requests we had with Flux. For example, doing reconciling the cluster state from multiple sources. So the Kustomize Controller is able to do that using sources as a reference. It can generate manifest with Kustomize, and this is not only specific to, so you don't have to have customized overlays in your repository. You can also have plain YAMLs, and the controller will detect, okay, there is no customization here. I have to generate one on the fly and applies it. So you can think of Kustomize as a way of implementing the controller. Is not a requirement for your actual repositories. Different to Flux, what the Kustomize Controller does, you can tell it to validate the manifest before it applies them, and it can use the Kubernetes API validation. And that's way more powerful than just validate with client dry run. For example, let's say you mistype the type of a service. Instead of cluster IP, you say, I don't know, load balancer, right? That kind of error will not be caught by just doing a validation on the client side. You need to actually trigger the Kubernetes API admission controllers and validation controller to determine if manifests are valid or not. And this also will trigger, let's say, gatekeeper OPA rules and so on. And if the validation fails, then you'll be notified before, and it will never try to apply. So with this step, we try to add more observability to what's going on in the reconciliation. Kustomize Controller also addresses the multi-tenancy feature, where, let's say, you have multiple teams that are sharing the same cluster. And instead of running for each team its own controller, the Kustomize Controller can impersonate service accounts. So you can use the same reconciler and tell him, hey, when you reconcile this particular source, use this service account, and you can limit what changes are allowed in that source by just specifying a Kubernetes service account. So we are not coming with a new RBox system. We just use the underlying things that Kubernetes offers, like service accounts. It also does health assessment, and this is linked to another feature where you can define dependencies between workloads. Let's say you want to apply first, when you bootstrap a cluster, you want, let's say, to install Istio first, and then you want to install your apps. Because your apps, if you are running inside a service mesh, they need to be injected. So the Istio injector must run before everything else, and customization API that the Kustomize Controller implements allows you to define this type of relationships between workloads, between various infrastructure items inside your cluster. It also does garbage collection, and for everything it does, it issues events, and those events can end up on Slack, Discord, and we'll be adding more options here. This is how it looks. You define a custom resource called customization, and you reference the source. Where are those manifests coming from? Which path? And you can specify dependency, you can specify health checks, enable, disable garbage collection, and so on. This is how fleet management could look like. It's just an idea that we could have a fleet controller that provisions using cluster API provider provisions clusters. Then it deploys on those clusters source controller, Kustomize Controller, Helm controller, and then programmatically does rolling deployments of workloads between these clusters by operating on these custom resources. Now, if you look at this, there are a bunch of YAMLs here, right? You have to write a lot of custom resources in YAML format to make this work. So to improve the situation and have a Flux-like experience where you just run a command, install it, and everything works, we've developed a command line tool called TK from Toolkit. And the command line allows you to provision Git repositories, allows you to set up authentication for them with deploy keys or with SSH or something that's token-based. You can also do all the operations that you need on the components, like installing them, upgrading them, removing components, adding components, running checks to detect if the GitOps Toolkit components are in a good state, and of course, uninstalling and cleaning up the whole cluster. It also has, it allows you to do operations with sources and customizations. And it has all sorts of validation in place, so it makes things easier than just writing this in YAML. And it has other features like forcing a manual sync of the whole cluster reconciliation, or you could also suspend and resume different types of apps that you have inside your cluster. I'm going to demo this right now, the Bootstrap command. What the Bootstrap command does, it creates a Git repository, or if that repository already exists, it uses it to configure a particular cluster. It sets up deploy keys. It gives access to particular teams to be able to modify or open pull requests on that repository. And of course, it fully automates the Toolkit components installation or upgrade. The command is idempotent, so you can run it as many times as you want. And we plan for the Bootstrap, we plan to offer the Bootstrap as a Go library. So if you want to build something on top of the toolkit that automates all of that, you'll be able to do it with just referencing our library. How much time do I have?
Around 10 minutes.
Okay. So I have a GitHub organization here, and I'm going to use this organization to create a Git repository to manage my fleet of clusters. And I'm going to run a command. So I've installed the TK CLI, and I'm going to say, I want to bootstrap a new cluster using the GitHub provider. And I'm giving it the owner, the name of the repository that I want to create, what teams should have access to that repository. And I'm going also to specify a path where all the provisioning manifests will be configured. Now, for this command to run, I've exported my GitHub token that has enough permissions on my organization to create the repository. So if I'm going to run this command, what will happen, it connects to the GitHub API, it validates my token, everything is okay. It has created a repository for me, it has added the teams. Now it generates the manifests of the components, because I haven't specified a list of components here. It will install everything that's in the default. So that's source controller and Kustomize Controller for now. And if I'm looking here, we should see that a private repository was created. You can also create a public repository. You can also create this repository on a personal account. It doesn't have to be an organization. Now it has started to install all the custom resources, the controllers. Now it checks that the controllers are healthy on your cluster. on my cluster. And it also has configured the deploy key for me. And it pushed that deploy key to GitHub. And now it does the first synchronization with between the cluster and the repository. So, okay, let's look what happened here. So we have a directory called staging cluster, and inside that, the staging cluster directory, it's a new directory called GitOps system. Here, this is the name of the namespace where all the components are being installed. And we have all these objects that are telling the cluster to use this repository as the way to manage the cluster state. If we look at what happened on the cluster, get namespaces, we see that we have a GitOps system namespace. And now here in my repository, I could just add more things like deployment specifications, namespaces, whatever, and they will be applied on my cluster. So this is how, let's say, Flux works today. But instead of doing that, I'm going to add a new source as a trusted source on my cluster. I'm going to run a different command. And I'm creating a source for my web app that's coming from a public repository. And I'm specifying, okay, I want to synchronize with the master branch. Every 30 seconds, the source controller should check if there is a new commit or not. And I want to write. So this command generates a YAML file, and I want to export this YAML file here. But before that, I have to clone the repository. Oh, sorry. So I'm going to clone the fleet infrastructure repository, navigate inside it. Okay. Now I'm going to create the source definition, and it has written a YAML file on the inside the repository, and then I'm going to define a reconciliation loop for things that are in that repository. And in the web app repository, there are a couple of things. There is a deploy web app common directory that contains things like namespaces, service accounts, all the things that the web app needs as a requirement. So I'm going to create customization for that. Then I'm going to create a new customization for microservice that's part of the web application. Let's say this is the backend microservice. And here I can define more things. There is a new path here, and I'm also adding a health check. I'm saying to Kustomize Controller, hey, after you apply that, verify that the backend is healthy by doing a health check on the deployment. And do not try to reconcile the backend if the common definition is not ready. So this is how I can define dependencies between things that are making my web app. Okay, so I'm creating this file as well. And finally, I'm going to add a front-end microservice reconciliation definition. And here I'm saying the front end depends on the backend, and the backend depends on this common definition. So I'm creating this dependency tree between the components of my web app. Okay, now I have these files on disk. I'm going to.
Could you show some of them quickly to illustrate what they look like?
What?
Could you also show some of the YAML files to illustrate what they look like, maybe in the GitHub UI?
Yeah, sure. So now I have committed all these things, the source definition of my web app and all the components that are making my application. And what I can do now, I can look at the cluster with the tk command that will list all the customizations that are present there. And we see right now there is only the GitOps system declared, and soon there will be the 3 customization I have just pushed. And if we look at the there, now common has been reconciled, and front-end and back-end are freezed right now because their dependencies are not ready. So back-end tells me web common is not ready, and front-end tells me, hey, back-end is not ready, so I'm not going to try to reconcile all this stuff. And the Kustomize Controller will keep checking the dependencies, and once common has been acknowledged, it retries the backend reconciliation. Now it has started, and at the end it will reconcile the whole thing. So if we look at my Fit infrastructure repository here, I can see there is a source definition. I'm going to make this bigger. All right, so I have a source that reference branch on this URL. Then I have, let's say, the web common definition. Reference is the Git repository, the path, the interval. So all these fields that I have specified in the CLI have been created here in the custom resource. Of course, you can create this manually and just push them to Git. The TK CLI is just there to make things easier and add more validation to the whole process. Now we go back to the cluster, we see that everything has been reconciled. And if I'm going to look at the namespaces now, I see there is a web app namespace, and I can do -web app, show me all the pods. I see there is a backend and the front end. Now, if I'm going to delete one of the customizations inside the repository, what the controller will do, it will garbage collect everything that was applied through that customization. So that's one level of garbage collection where you can delete everything. Another level is if I'm the owner of the podinfo repository. Now, if I'm going into that repository and I'm going to delete something, let's say, or replace something, a service account, I'm going to change the service account name, then there will be a different type of garbage collection where it looks at all the things that have been applied before. And if something changed, all the objects are being removed for me. So those are the 2 types of garbage collection that we've implemented. So that was my quick demo. Going back to the slides, do I still have time? One thing that you can do with the CLI and also through Git, you can suspend a particular reconciliation. So let's say you have an incident, you have multiple apps or multiple infrastructure items running inside your cluster. Instead of just, if you want to get in there and do some debugging, you want to edit things, then you'll be fighting with the reconciler. The reconciler will detect your changes as a drift and you'll reapply them. So one option will be you have to scale to 0 or stop the reconciler altogether, but that will affect the whole cluster, right? So instead of doing that, you have a command called suspend that changes the status of the particular customization, and the Kustomize Controller will not try to reconcile it anymore until you resume that operation. So you can suspend something, debug it, change it, then those changes you can put it back in Git, resume it, and the reconciler will override all the manual changes with what's now in my Git repository. So that's one feature that we have through the CLI. Now, getting back to Flux and Helm operator, we envision a future where Flux v2, Helm operator v2 are a result of the GitOps Toolkit components, where you assemble some components and you have Flux, you assemble other components, you have Helm operator, and others as well. We've started to work on a roadmap, have the link here. if you are interested, if you want to help us out, if you want to contribute to the Flux future, please reach out to us. Nothing here is set in stone, not the APIs, not the way the controllers talk to each other. This is just the first step in experimenting with different things. So please take a look at the roadmap, especially if you are a Flux user and if you have, things that you really want to get in here. Open an issue, talk to us, and we'll make this happen. What about flagrant progressive delivery? Nothing quite changes. You can still have canary manifests inside your app repository, and it does the same thing. Any other Kubernetes controller should work with the toolkit. You don't have to change the way things work. It's just that the toolkit allows you to add more specialization or have more observability to your pipelines. So no changes here. There are a couple of links I want to share with you. We have started working on official documentation for the toolkit. It's ready for you to try it out. We have a get started guide in there, and these are the current repositories. Every component has its own repo, has its own specification and documentation, and everything is put together in the toolkit fluxcd.io website. So please try it out, and looking forward to your feedback.
Thank you a lot. That's a great presentation. So there was one question which was really relevant here, and Flux has this watch register, image registry for new tags, and then write to Git feature. So he's thinking about that. Does it fit into our architecture, or what's the plan?
So here in the roadmap, we have defined a couple of things. So in order to get to a Flux v2 that's backwards compatible with Flux v1 main features, we are trying to get on pair with Flux read-only features. And we've listed here a couple of things for that to happen. Also, we want to include notifications into all of this and have a specialized controller that does outbound notifications. And another big item here is to offer a dedicated component that can replace the image update feature in Flux v1. So instead of having the image update feature built into Kustomize Controller, source controller, I don't think it makes sense. It makes sense to have a dedicated thing that if you want this feature, will be installing that component. And we don't plan to support the current Flux annotations. We'll be doing this through custom resources. So you'll create a custom resource that defines the policy of what images you want to be updated, what kind of sample ranges, and so on. And for Helm operator as well. Other questions?
I don't see any other questions at the moment. Anything from the other? Let's see.
I have a question.
Yeah.
So this changes quite a lot in terms of Flux. How, I know this is very early stage, but when do you see this sort of being rolled out and sort of replacing Flux as it is today?
I think the first step will be to get the read-only feature parity on. Then we plan to provide the in-place migration command to the toolkit CLI, where you could just swap Flux with these components. And that should be achievable in the following months if we want to pursue this. But we really want feedback from the community on the API design and things that we can change right now in the core components before we go even further. And yeah, after we we manage to get the read-only feature parity, then we'll be encouraging current Flux users that don't depend on the image update feature to try it out on, I don't know, dev or staging environments. So that's step one. And afterwards, work on the image update feature.
Cool. So now one more. Do you envision that Flux might expose higher order CRDs to wrap up a Git repo and Kustomize Controller into a single object? Just trying to think of what the Flux interface might look like.
Yeah, I think the current toolkit objects are things that can be automated through other operators. In my example was a fleet operator that was creating sources and customization based on some other thing called an environment. Other ideas are around profiles, how you can define a profile for your cluster. So let's say you can have a profile custom resource that there you can specify Git source, there you can specify what things make up that profile, and that controller, that operator will be creating all the underlying sources, customization, relationship, and so on. I think the toolkit, we try to have the toolkit as a low-level implementation, so others can build more high-order objects on top of it.
Makes a lot of sense. So another question, can you do the same things than Argo CD to sync Helm charts from a private registry for a specific minor version?
Syncing a Helm chart from a private?
Yes, I'm not either, completely sure.
Yeah, okay, let's take
but
that.
Maybe if you a bit talk about the Helm integrations, that clarifies.
So our plan is to support all the current Helm operator features, and one of it is to synchronize with private Helm repositories, private Git repositories, and so on. Our approach with Helm is different to others in a way that we don't use Helm as just a templating engine. We use Helm, we use the Helm packages, and when Helm operator and the future Helm controller will install a Helm release, you can do Helm list, you can do Helm test, you can do all these things through the custom resource. So yes, we will be fully integrate with all the Helm features and what we currently have in Helm operator.
Cool, thanks. Yeah, and if anybody has any questions after this, or if you're watching the recording, I'm sure that, so, or let's ask it like this, where can people find you, Stefan?
So people can
or the team.
Come to the Slack. Everybody's in the Slack. That's the best place to find us. We're also looking at other options like GitHub discussions, because there's a lot of different places where people are interacting with the Flux GitOps engineering team now. It's becoming a little bit overwhelming, but just for the time being, please come to the Slack, okay? And also look at that GitOps community link that I posted in my presentation, please, which has lots of info.
Yeah, so there are a couple of Slack channels. One is the CNCF Flux channel. The other one is the Weaveworks user group. We also have there a couple of channels for GitOps, for Flux. There is also the Kubernetes GitOps channel. So yeah, we have many Slack channels. We try to watch for feedback. And yes, I think we'll be looking at GitHub discussions for a more structured way of receiving feedback. But until we manage to enable that, we'll be also creating GitHub issue templates for things like API proposals or design proposals of the whole thing.
Cool. And maybe the final word is where to contribute. And I think you have the page open, probably.
So Now each controller has its own repository. So if you want to contribute, for example, you want to add a new source, or you want to improve the current source implementations, you'll be looking at opening an issue and a pull request on the source controller repository for customized something. The toolkit CLI, it's in the /toolkit repository, and for example, the future image controller, image scanning controller thing will have its own repository and so on. But we'll try to use the toolkit repository as the main repo, and yeah, and with GitHub discussions in there.
That's great. Any final words from the speakers or any other organizer?
Yeah, I think we are out of time.
Yeah.
So yeah, I just want to say thank you to both of you for being here today. That was really awesome. And yeah, just thank you for today, and hopefully see you next time. We will have a short break now with the summer vacation, and hopefully we will be back in August with some more virtual events, maybe perhaps even some physical events. We'll see how it goes. So yeah, thank you, and goodbye.
Thank you very much. Bye.
Thank you, Stefan. Alexis. Bye.